The dark sky that shouldn't exist. Imagine stepping outside one night. No stars, no Milky Way, no distant galaxies. Just darkness. Not because clouds are blocking the view, not because the universe has ended, but because everything else has disappeared beyond our reach. In this future, the night sky is empty, not black with mystery, but black with absence. Every galaxy outside our local group has vanished, stretched so far away that their light will never reach us again. This is not science fiction. This is not a theory about another universe. This is the inevitable future of our own universe. And the reason is something we barely understand. A force that dominates reality, controls the fate of everything, and yet remains invisible. Today, we're diving into the expansion of the universe and the dark energy that's tearing it apart. Chapter 1. The discovery that shattered the cosmos. In the early 1900s, humanity believed the universe was simple, static, eternal, unchanging. The Milky Way was thought to be everything. Then came Edwin Hubble. Using one of the most powerful telescopes of his time, Hubble began observing faint, blurry nebulae in the night sky. But something fell off. These objects weren't inside our galaxy. They were entire galaxies of their own, millions, even billions of stars each. But Hubble noticed something even stranger. The light from distant galaxies was shifted, redder than it should be. This phenomenon is called redshift, and it happens when light waves stretch, just like sound waves from a passing siren stretch as it moves away. The implication was shocking. Every galaxy, in every direction, was moving away from us, not just drifting, racing outward. The universe wasn't static. It was expanding. Imagine the universe as the surface of a balloon. Each galaxy is a dot on that surface. As the balloon inflates, every dot moves away from every other dot. No center, no edge, just expansion. This discovery shattered our understanding of reality. Because if the universe is expanding now, it must have been smaller in the past, which leads to a single, unavoidable conclusion. The universe had a beginning. Chapter 2. Expansion wasn't the end of the story at first. Scientists assumed the expansion would slow down. Why? Because gravity pulls things together. Galaxies have mass. Mass creates gravity. Gravity should act like cosmic brakes. The universe should expand, yes, but more slowly over time. For decades, this made sense. Until the late 1990s, two independent teams of astronomers were studying distant exploding stars called Type Ia supernovae, cosmic mile markers that help measure distances across the universe. What they found changed everything. The universe wasn't slowing down. It was speeding up. The expansion of space itself was accelerating. Something was overpowering gravity. Something was pushing galaxies apart harder and harder as time went on. And nobody knew what it was. Chapter 3. Gravity is losing the war. This discovery posed a terrifying question. How can expansion accelerate? In everyday life, things don't just speed up without energy. You don't throw a ball and watch it accelerate forever. Something must be adding energy to the system. But here, the universe itself was gaining speed. Gravity, the strongest force on cosmic scales, was losing. The further apart galaxies became, the faster they separated. This wasn't galaxies flying through space. It was space itself stretching, and whatever was causing it was everywhere, even in the emptiest regions of the universe. Chapter 4. Dark Energy. The invisible ruler of reality. Scientists gave this unknown force a name, dark energy. Not because it's evil, not because it's mysterious on purpose, but because it's invisible, undetectable directly, and profoundly misunderstood. Dark energy makes up about 68% of the entire universe. Let that sink in. Everything you've ever seen, stars, planets, galaxies, black holes, all matter combined, is only about 5%. Dark energy outweighs everything else. So what is it? We don't know, but we have ideas. One leading explanation is vacuum energy, energy inherent to empty space itself. In quantum physics, empty space isn't truly empty. Tiny fluctuations constantly appear and disappear. If space has energy, then as space expands, more energy appears, which means more expansion, which creates more space, which creates more energy. A runaway effect. Dark energy doesn't pull. It doesn't clump. It doesn't weaken with distance. It pushes. Every cubic meter of space contains a tiny amount of dark energy. And when the universe was small, it didn't matter much. But as space grows, dark energy wins. Chapter 5, Faster Than Light. Without breaking physics, visual cue. Galaxies drifting beyond a glowing horizon. Here's where things get weird. Some galaxies are moving away from us faster than the speed of light. Doesn't that break Einstein's rules? No, because they aren't moving through space faster than light. Space itself is expanding. Imagine ants on a stretching rubber band. The ants aren't running. The surface beneath them is growing. Einstein's speed limit applies to objects moving through space. It says nothing about how fast space itself can expand. This creates a boundary called the cosmic event horizon. Beyond it, galaxies recede so fast that their light will never reach us, no matter how long we wait. One by one, galaxies disappear from view, not because they're destroyed, but because the universe is pulling them away faster than light can travel. Chapter 6, The 3 Possible Fates of the Universe. So where does this all lead? There are 3 possible endings to the universe. 1. The Big Crunch. If dark energy weakens or reverses, gravity could reclaim control. Expansion stops. The universe contracts. Everything collapses back into a fiery singularity. A cosmic rewind. But current observations suggest this is unlikely. 2. The Big Rip. If dark energy grows stronger over time. First, galaxies drift apart. Then stars are torn from their systems. Then planets ripped from stars. Finally, atoms themselves are pulled apart. Space stretches so violently that nothing survives. Time itself may end. Terrifying. But again, evidence suggests this isn't our fate. 3. The Big Freeze. Our likely destiny, the most likely future is quieter, colder, lonelier. Expansion continues forever. Galaxies beyond our local group vanish beyond the horizon. Star formation slows. Existing stars burn out. Eventually, the universe becomes dark, cold, and empty. Not with a bang, but with a whisper. This is called heat death. Energy spreads thin. No gradients remain. No work can be done. Time continues, but nothing happens. Conclusion. The luckiest moment in cosmic history. Here's the haunting truth. We live at a cosmically special time, early enough to see distant galaxies, late enough to understand the universe, briefly positioned between chaos and silence. In the far future, intelligent beings may exist, but they'll never know the universe is expanding. They'll see only one galaxy in endless darkness. They'll have no evidence of the Big Bang. We are lucky to exist when the universe is still bright enough to tell its story. And for a fleeting moment, the cosmos is visible and trying to be understood. Call to action. If this video expanded your mind even a little, consider subscribing to Lumix Space. We explore the universe, one mystery at a time, because the universe is getting darker, and knowledge is how we keep the lights on.